So we've done a lot of solving. We're going to start solving different types of equations here. Ones we're going to solve might be a little uncomfortable at first, but I promise this process will become easier as time goes on. We're talking about solving literal equations. So first thing for you is, what is a literal equation? A literal equation is an equation where we have two or more variables. We're used to seeing only one type of variable, normally x, but we're going to be focusing on equations like the one you see, the x plus y equals z, that now has multiple variables in it. You're very familiar with these types of equations, not calling them literal equations necessarily, but you're familiar with them in formulas. Formulas just have more than one variable in it, and they're showing a specific relationship. So for example, the ones you can see down there, you don't need to record all of them, but some of them more familiar than others. The first one is, you have the area of the triangle equals 1/2 base times height. So that's a formula for area of a triangle. You've got a distance formula, D equals RT, distance equals rate times time. You have a Celsius, Fahrenheit. This is a temperature conversion formula. And then the last one, P here, stands for perimeter, length and width involved. Those are formulas you may or may not be as familiar with, some of them, but formulas are showing a specific relationship through use of variables. And so this is something you see in science and math all over the place. So just to show you are familiar with them. When we talk about literal equations, what we're going to be doing is actually solving them, and we're going to be solving them for variables. Now, if you notice, we have more than one variable. Looking at the steps here, we're going to talk about how you're going to approach problems like this, where you're given a literal equation and you're asked to solve for a certain variable. So I'm going to show you an example real quick, and then we'll come back to the steps. You don't need to write this one down, but if you notice, on the left, we have a regular equation that we've been doing this far this year, pretty easy one. And then on the right, we have a literal equation. So the difference is we're still solving. You see, we're still solving for a variable in both of them, but now we have more than one variable involved in the equation. So when we go about solving for a variable with a literal equation, the first thing you're going to do is locate the variable you're being asked to solve for. We have more than one variable now, so you want to make sure you're focusing on the correct variable. The steps from here look very similar to things we've done already. We're going to identify the operations that are being done on the variable. The order that they're happening in is very important as well, so that we can solve. Step 3 is the actual solving, that we're going to use the inverse operations to undo those operations and isolate the variable. The goal is still the same. We want to get the variable alone. We're going to use the same general process. It's just going to look a little bit different because we're not just dealing with numbers. So let's look at the quick examples I have here to illustrate for you, and you don't need to write these ones down. But when I'm looking at solving for a variable, like on the right side here, I was looking to solve for b. On the left, I was looking to solve for x. If you look at the setup, they look very similar. Process is the same. What operation is happening? We're adding on a, we're adding on 5. So we're going to use the opposite operation to isolate our variable. So on the left side, that was subtraction of 5. When we have our literal equation on the right, we're going to use the same set of operations. So if I subtract a from both sides, on the left side, that cancels out a, and I'm left with b alone. And my answer here is, that's not a 9, that's an a. 3 minus a is what I was left with, and I can't combine that or simplify that because those are not terms. And that's the thing that probably makes people the most uncomfortable. So a second example, just to show how this still, again, I'm solving for b, how this still relates to the equations we've solved. I'm solving for x. I divide by 3 to get x alone. Because the operation that's happening to b is multiplication, I'm going to divide by a on both sides, and I'll be left with b is isolated. We've solved for that variable. So those are some basic examples just to see how this relates back to the equations we've been solving. Now let's do a couple that maybe step the game up a little bit. So on your paper, you're going to see your I do's and you do's listed out, but you're not going to need to record this part here where I'm telling you what variable to solve for. So if we have the area formula for a triangle, we're seeing the same formula again. Area equals 1/2, and I'm going to draw in the multiplication signs to help me out with the next part. Area equals 1/2 base times height, where b is the length of the base and h is the height. Not the important part. What's important is, for us, just solving for the correct variable. So step 1, find out what variable you're solving for. Step 2, identify the operation. I have a lot of multiplication going on. I'm multiplying h by b, and I'm multiplying h by 1/2. So how am I going to solve for h? I'm going to use the opposite operation, step 3, division. So I'm going to divide by b. On both sides, that will cancel out b. I'm left with a over b equals 1/2 times h. How do I get rid of this 1/2? Well, it's multiplying, so I'm going to divide both sides by 1/2. Now, reminder, and it'll pop up here, reminder that dividing by a fraction is the same as multiplying by the reciprocal. So instead of thinking of this as divided by 1/2, I can think of this as multiply both sides by the reciprocal of 2 over 1. On the left side, that cancels, or sorry, on the right side, that cancels this out, so I'm just left with h. On the left side, I get 2 times a is 2a, 1 times b is b, so my answer is that h is equal to 2a over b. H is now isolated. So pick out the variable, look at the operations, and do the opposite. So you're going to try this one, pause, and try it and come back. So we're solving for I. If I look at my equation, I have f equals I minus gt. This can turn into a very different problem if you solve for a different variable. So make sure you're isolating the correct variable. I'm isolating I. So to get I alone, I has a subtraction happening to it. So how am I going to undo that? I'm going to do the opposite operation. So I'm going to add to cancel out this gt that's being subtracted from the I. So I have f plus gt. Those are not like terms, so I can't combine them together, and that is equal to I. Sometimes it's just a simple step. The answer may not look any more appealing to us at this point, but we'll get into like the whys later on. So that's the first you do, pretty simple. The next you do has a few more steps. So if you need to kind of go step by step with me through the next you do, then by all means kind of work along and pause. Oh, and I added the pause button in the corner so that to remind you to pause to try the problem. So for this problem, I have s equals, and this has to do with typing speed, but the purpose of the formula isn't really the key here. I'm going to try and solve this formula for E. So I want to think about what operations are happening to E. Then I'm going to undo those operations. Remember, when you talk about the operations that are happening to E, you have to talk about the operations that are happening to E. You want to not only do the opposite operation, but you want to do them in the opposite order. So think about what's going to happen to E here. I'm going to be multiplying by 10. I'm going to be subtracting with W. And then I'm going to be dividing by M. So as far as order of operations go, to undo these, I'm going to get rid of the M first because that was the last regular order of the operations. So undoing would be opposite operation and opposite order. So the first step is I'm going to be multiplying both sides by M. I don't care if you list this as MS or SM, but either way, the M's are going to cancel out, and I'm left with W minus 10E. The next step, I need to get rid of the W. So I'm going to subtract both sides by W to get that W to cancel out. I'm left with MS minus W. These are not like terms because they are not the same variable. And make sure you bring that minus sign down. It turns into a negative sign. So I have negative 10E. I have E being multiplied by negative 10. So I'm going to divide both sides by negative 10. So my final answer canceled out I have E alone. E is equal to ms minus w over the whole thing over negative 10. Because when you're dividing the whole side by negative 10, not just whichever term you want to pick. You divide the entire side. So not something that looks that much more comfortable, but now we have isolated E alone. So the last two examples we have here are an I do and a you do, and these are ones we're doing now because they're going to come back and we are going to actually find this really useful in the next couple of units. We're taking an equation here with x and y, and we are solving for y. Now, this setup that we see, again, is going to become meaningful to us. This is not a formula, but a certain type of, close to a formula for us to use algebraically. And we're going to be solving for y a lot. So kind of this process you want to get used to. So think about what's happening to y here to figure out what operations we're going to do and undo. If you look at the y, if I took a number and I plugged it in for y, what's the first thing that would happen? We would multiply it with this 3. The next thing that would happen to it is we would combine it with the 6x. So if I'm going to get y alone, I want to do the opposite order of operations and undo. So this 6x, I need to get rid of first. How am I going to get rid of the 6x? Well, it was being subtracted, added, whatever you want to say here with the negative, so you could make this plus negative 3y, and that would be fine. But it's being added on. So I'm going to cancel this using subtraction because 6x minus 6x would cancel out. So I'm going to do minus 6x on both sides. I am left with, and again, I move the negative sign here to the 3y. This is negative 3y because this cancels out. On the right side, here's where you got to make sure you're checking your work and checking your thought process. 12 minus 6x does not combine together because those are not like terms. And with literal equations, we're going to have that process a lot. The last step is we are going to divide to get rid of this negative 3 because it was being multiplied. We're going to get y alone. Now here's something different that I'm going to ask you to practice with these two especially. We have a bunch of numbers involved, so we can actually do our division. The thing is, we are dividing the entire side by negative 3. So we're dividing 12 by negative 3 and negative 6x divided by negative 3. So we're going to do 12 divided by negative 3 is negative 4. And we're also going to divide negative 6x by negative 3, which is positive 2x. So you can write your answer like that, or you could say it's 2x minus 4. And I don't know why the pen did that, but I think you guys can still read that. Either one of those answers would be acceptable, but making sure you don't combine like terms or non-like terms. These are unlike. And making sure that you divide all your terms all on one side by that value. So go ahead and pause and try this you do. Again, we're trying to get y alone. So we're going to add 2x to both sides. We're going to get rid of 2x first. So left with negative 7y equals 14 plus 2x. Make sure you bring the minus sign down. We're going to divide both sides by negative 7. We divide 14 by negative 7, we get negative 2. If we divide 2x by negative 7, I have a positive and negative, so I'm going to end up with a negative value. And 2 and 7 do not divide evenly, so I'm just going to leave it as a fraction of 2 7x. You could also leave it as 2x over 7, and that would be fine. But that minus sign, that negative answer becomes my minus sign. So either that, or if you wrote it in the other order, that would be fine as well. We're going to become comfortable with this now, or a little bit more comfortable with this now, so that when we come across it later, it's going to be super easy for us. So that's solving literal equations. We have practice we're going to do over the next couple of days to get you more comfortable with it.